Okay, so today is 1.8 roots, and we're dealing with square roots and cube roots today. And here's the definition of a square root with an example. Zoom it in, or you want to move up? You can move up. There's this spot right here. You guys need to move up at any time. Just, yeah, right there is fine. Okay. So, a square root is one of two equal factors of a number, and the example right here is the square root of 4 equals 2. The 2's are the equal factors of 4. These little lines, I think you've used these before in elementary, but we call them like factoring trees. And sometimes if you have a real big number, we just keep factoring. Raise your hand if you've seen this factoring. Good. So that's not new stuff. And then we have things called perfect squares. And I know you learned this in elementary school because the teachers made you draw out a chart or fill in a chart. So it was a while back, but I know you've seen it. I'm not making you fill in a chart today. You're welcome. Or ever, for that matter, for this. But numbers such as 1, 4, 9, 16, and 25, this BC is because they are squares of integers. So 4 is a perfect square because 2 squared is 4. They have to be integers, not decimals or anything.
Does that say 2 or 20 something?
This right here?
Yeah.
It says 25. And you can't see it. That would be good. You can let me know. There we go. Better? So that's 4 is a perfect square. 9 is a perfect square because what two factors make 9 that are 3 and 3? You know this. Awesome. Okay, we have this. This is called a radical sign. So when you hear people talk about radicals, they're talking about roots, like either square roots, cube roots. Math doesn't stop at cube roots. It's just that in Math 8 we stop at cube roots, but it goes on to 4th and 5th and 6th roots. We don't need them here though. When you guys start building bridges and roller coasters, you might need them. They come up in calculus. Okay. So here's something interesting. And this, I put a box around it because they're really emphasizing it this year in Math 8. So if you have an equation, if n squared, just say n's any number, any integer, equals a, this being the answer, a being the answer, then n has to equal a plus or minus of the square root of a. This plus or minus symbol might be new to you, but this is going to happen a lot in Math 8 and in Math 1 next year, this plus or minus. So an example, oh, and actually if you took Advanced Math 7, you saw plus or minus. Yeah? Quadratic equation. So an example here, we have n squared equals 4, n equals plus or minus 2. And it works for fractions too, so I wanted to show you that if you have n squared equals 1/4, that answer is plus or minus 1/2. Can anyone raise their hand and tell me why we need the plus and the minus? Why it could be a negative? This just means it's a positive 2 and a negative 2. Anyone know why it could be a negative? Anyone? What happens when you square a negative number? If I do negative 2 times negative 2, what's my answer? Positive 4. So I could have a negative number, right? If I square it, I can still get the 4. Does that work with cube roots? Does it work with fourth roots? Yes. long as you have a pair of negatives, you get a positive. Here's some examples of common square roots. If you know all of these, you don't need to write them down. But some people like to have a little chart to look at, like a cheat sheet. So these are all of them up to 15. Obviously they keep going, but these are the most common. So square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and so on. I'll let you guys write those down. I can see you like those. Okay. So you can see most of you, I think, have memorized things like up to 6. I think most of you have memorized 7 and 8. Maybe 9 is sometimes you forget. Most people know square root of 100 is 10, because 10 times 10, that's an easy one. People don't always know 11, 121. And a lot of people know 12, 144. And then after that, we're like, I don't know, let me look at my chart, right? But these are the common ones. 13 and 14 are easy because you just switch. This is 169, this is 196. So you switch the last 2 digits. Okay. And then sometimes we have negatives. Of course we do, right? Square roots of negative numbers equal no real numbers. You can write no real if you get one too, to abbreviate. So square roots of negative numbers equal no real numbers. The example would be this one. If you get that, like any negative, but let's just put -4 in there, then your answer is not -2, or not 0, or not IDK. Okay? It's no real numbers. Although, does anybody remember on the first day of notes when we made our number system chart, you know, with the boxes? Does anyone remember what I said would happen sometimes if you get a negative root? What do we call those later on? What? You remember? What, Julianne?
Imaginary?
Yeah. So actually, we can have imaginary numbers, and imaginary numbers are not real. So if you wrote imaginary, I would accept it, because I taught you that. But no real number is the same as imaginary, right? Okay. And that would also be in calculus and advanced math. So here's the tip of the day. This one's free. Don't get confused, because if the negative is on the outside of the square root, the answer would be negative whatever that root is. This does not equal no reals. This actually has an answer. There's one like this in your homework or classwork. I can't remember, but it's in there. So I don't want you to be confused. Any questions on square roots? This we've seen a little bit of? Yes.
So like if the negative sign is outside of the little like line thing.
The radical, yeah.
Yeah, there's actually like a number for it. Like
And then you just put the negative on the end. Perfect. Okay, we're going to look at cube roots. Second page of notes is cube roots. So a cube root is one of 3 equal factors of a number. I'm going to zoom that in. I wrote smaller, I guess. It's taking time. And it really doesn't like me today. Oh, there it is. Okay, cube root. One of 3 equal factors of a number. Just like square roots, it had 2. This is 3. Perfect cubes, just like we have perfect squares, are numbers such as 8, 27, 64, because they are the cubes of integers. For instance, if you break 8 apart into 3 equal numbers and 3 equal factors, you have 3 2s. 27 would have 3 3s, and 64 has 4 4s. Most people know 8 and 27, but after that they're like, I don't memorize these, because do you think these get really big really fast? Yes. As the exponent increases, that numbers grow exponentially. So very fast. I have another lesson that goes with this that teaches you how you can make a lot of money. We'll save that for another day. All right. The symbol here is this little 3 with the radical. An example would be this one. The cube root of 125 equals 5, because 5 times 5 times 5 is 125. Do you think that you would do this work in your head or on paper? No. You'd use a calculator, right? And at home when you're doing homework, you'd use the MyScript app, because it's really simple. And yes, you can draw your radical on that app and put in the little 3. It works. Another example, this one has a negative. I put a star by this. Because you notice here in square roots, that would be no reals. But in cube roots, you can actually get that number. Because negative 3 times negative 3 is 9, times negative 3 is negative 27. So it works in cube roots. The negatives work in cube roots. Okay. All right, here's some common ones. I only went up to 6. I know that when you guys take your test at the end of the unit, this last one will be on there, the cube root of 216, but it doesn't go any further than that. So all of these up to the 6th will be on there. So cube root of 1 is 1, cube root of 8 is 2, cube root of 3 is 27, cube root of 4, 64, cube root of, 64. Cube root of 125 is 5. Cube root of 216 is 6. So if you memorize those, then you don't have to use a calculator. And to examples. You can cube root fractions and square root fractions. You know that, right? So you just treat them each separately. Just like when we had them raised to powers, we treated them separately. So here I can have this one, 1/8 would be 1/2. And if I have a negative cube root of 27, I put the negative at the end. Just like in square roots. On your calculators, you guys, you have a button. I know everyone has a little bit different calculator, but normally, I'm going to write this down for you. Normally the button on the calculator, if you're not using the app, calc button, looks like this. Have you seen that button before? X to X and then Y. But you have to hit your second, you know, the second button to get there. It's like above the other button of Y to the X. So I'll show you on my calculator. There's a button. Looks like a button now, right? Okay, so on mine, if you can see, it's kind of glary, but please go like that. So I have mine right here. To see it's Y to the X, and then above it is cube root, or it could be really any root, could be 4th root, 5th root, but you can use this later on in math too. So I don't know how mine is, but let's see. I might have to put the number in first, cube, and then do it, of 64. Nope, that one didn't work. So you have to see which one yours works with. I might have to go 64 and then 3. Yep. So you put the number inside the radical, then hit second, then that, and then the 3 for the cube root.
Mine has a thing with the radical, but there's an X instead of a 3. It looks like this kind of.
Mine has an X.
Oh.
Can you see it? It's really tiny. Anyway, that's the calculator button, and they're on the smartphones. It's the same, I believe. It's the same button. So if you're using that. But in class, you know, for quizzes, we have to use these, so I teach you that. Okay. Any questions on cube roots? Any questions on square roots? Okay, very quickly, I'm going to show you estimating roots, because we do have time. It's a very short lesson. It's 1-9 in your book, so if you want more information on it, it's there. But I'm not going to give you a ton of information because it's really not that difficult. And some of you might have done some of this in Math 7. So estimating roots happens when you're given a number, like a square root of, question?
I believe.
Okay. Did you get all that stuff written down? Okay. Yeah. If you always have to leave early, just make sure you come in to make up the quiz sometime. I know some of you have to do that. Okay, so sometimes we have to estimate a square root because we're given like a random thing. Like if I gave you the square root of 13, which is a decimal, I need to know what number is that closest to. Well, we know 1, the square root of 1 is 1, right? So if I gave you the square root of 13, what is that closest to? You can keep going up the number line, right? I'm going to show you what I mean. I started this, but I didn't finish. Okay? So if we have a number line, so draw a little number line. We're going to look at square roots first. We're not going to go all the way out here because you guys already have some of them. So at 0, you don't really need 0. But at 1, the square root of 1 equals 1. At 2, the square root of 4 equals 2. At 3, the square root of 9. So what's 4 going to be? Square root of 16. You get it? I'll keep filling in while you guys are writing. we're, like I said, we're only going to go up to 8 because you guys get it at this point, I think.
Is this it for the lesson?
Well, I'll show you cube roots too, but I'm not going to not going to make you write another number line, okay? This is it, pretty much. Okay, so I'll write the examples down here for you guys. So example 1. Once you have your number line. And I'll probably end up writing out one of these number lines and put it on the word wall so you guys have it, like with the square roots on it, even though there's a big number line already up there. So. Okay, so here's an example. Like, just say I want to know which whole number the square root of 83 is closest to. Okay? So the square root of 83, and this is what you do. You can look in your calculator, and you can actually square root it. Let's see. And it works out to, let me see if I did it right, like 9.1 or something. Because you know how the square root of 81 is 9? So this equals or approximates to 9.1. So what number is this closest to? 9. But if you didn't have a calculator, you could estimate and go, oh, I know square root of 81 is 9, so it's closest to 9. Yeah.
You could do this on my script, right?
Yes, you can do this on my script. Okay, let's do example 2 over here, save space. What if we have, let me see, what's a good one? The square root of 28. Without looking in your calculators and plugging it in, what do you think that number is going to be closest to? What whole number down here will be closest to? You can say it. 5. How did you do it though?
25.
Ah, you look at these, and 28 is closer to the 25. So I don't even know what this is, but I'm going to say the closest number would be 5. Just like this one. Sorry, we didn't write it, but 9. Okay? And then just, if you want to know, I'll do the square root of 28, which is 5.29. But you're not expected to get the decimal here. You're just expected to estimate what it's closest to. So sometimes it'll be a little bit over, so you go down. If this was bigger, like say this was the square root of 33, then we would go with that. What do you do if it's like right in the middle of the two numbers and you're like, it's either 4 this way or 4 that way? What should you do? What do we always do with decimals? We round up. There's probably not one like that, but just in case you know. So that's estimating roots. Now what if they're cube roots? It's the same thing. Okay? So I'll do one of those and then we're finished with notes. Example 3. We'll do a cube root real quick. So let's say we have the cube root of 320 and I want to know what that is closest to. Well, that's a big number. I didn't make you write that in the chart. If you look back a page in your notes, we only went up to 6, right? So we know it's bigger than 6. Anyone have a guess of what they think it is? What?
60.
Not that big. What?
15.
No, that's way too big. What?
13.
Nope. Ryan? 11? Nope. What?
8.
Maybe 8? Maybe 7? It might even be closest to 6. Should we find out? I think we should. So again, we type 320, hit the second, and that one button I told you about, 3 equals, 6.8. 6.8. So what whole number is that closest to?
7.
7. We round up. There we go. Got it? So remember, cube roots, they grow really fast. Those numbers get big really fast. Square roots, not so much. All right. Any questions on estimating? You just try to find what whole number is it closest to. Good? If I was you, I'd use my calculator. But if you're ever stuck without one, you can still do this by just knowing some of these numbers that you have memorized. All right.